So today we will be looking into punching machines, hence the name Closer Look on Punching Machines. So we will be talking about the punching machines, their working principles, and the technology that is grown as the punching machines. Uh, you know, have punching machines has come a long way since its since their invention, and also the well-known brands and the things to be considered when you are choosing a punching machine, and other things also. So, and this webinar is sponsored by Radcam Technologies Bangalore. We are uh, service-based industries and machineries and software providers. We deals with Euromac punching machines and we deal with metallic software from Israel that do CAD CAM programming for the all kind of sheet metal machines. So that's about Radcam Technologies. And today, I hope some of the people know that we did a webinar on a guide to sheet metal manufacturing a few days back with all my colleagues and everything. So in that webinar, we take a look. We took a look on uh, how the how to choose your machine. If you know you are doing a sheet metal manufacturing, what is the which machine is right for you, whether it's a punching machine or a laser machine or a water jet machine. uh, you know that suits your products. And we did a brief introduction about the punching machines. We did a brief introduction about the laser machines and a little bit about the water jet, and we give some bird view about the choosing the right machines in that respective area. So today we will be taking a deeper dive into a punching machine arena. So in punching machine arena, we will be looking how the punching machine works, or what are the quirks you can enjoy if you have a punching machine, and what is the category you should look when you want to purchase a punching machine. So that's the basic idea we have here. And during this webinar, if anybody has a question, you can put it in a chat box, or at the end of the time, at the end of the webinar, we will allow some questionnaires. We will see how the time goes, and you can ask that. So, or at the last slide, we have mentioned our mail ID and phone numbers. You can shoot your questions there also. So without any further ado, let's start our webinar, a closer look on punching machines. So okay, so punching machines. Punching machines are basically programmed to move sheet metal in X and Y direction to position it under a ram, which is ready to punch a hole or make a form in that. So usually, when we are talking about punching machines, most of the materials will process from 0.5 mm thickness to 6 mm. So that is the usual range we have. Uh, and as many of you know, the punching machines, the thicknesses it can process, most of the capacity should be awarded to the tonnage the machine has. So usually the machines will have a different kind of tonnages based on the technology and everything. So the ideal range for the punching machines is 2.5 mm to 6 mm thick. So in 6 mm thick, it's a little bit difficult to do a forming operations, but the punching and everything else is that's the green zone for the punching machines. And like I said, if this machine may also perform 3D forms like dimples, taps, screw threads, electric knockouts. I hope electric knockouts, like we will do when we are doing electrical control panels. We will do with the knockout knockout tool, we will create an impression, and during the wiring, they can simply knock out that part and take out the wire from that part. So like that kind of things, and lowers for airflow and everything. The forming operations are only possible in punching machines. You cannot do that in laser machines. So that's what I want to tell you. So that's where the punching machines come. If your machines, if uh, you have you know, a lot of forming jobs or a lot of punching, like 3D forms or something like that, you should go for punching machine. A laser machine might offer you a little bit higher productivity, but when it comes to forming, you cannot go anywhere else. So, okay, without speaking some well-known brands, it would be like hiding the things or something like that. Like I already told you, we are the dealers and you know contact point and service engineers and everything for Euromac in India. So Euromac is a well-known brand. It's from Italy. Euromac is from Italy, and you might have heard Amada. It's from Japan, and Murata is itself is from Japan, and we have Prima Power, and Prima Power is from Italy, and we have Trumpf, and Trumpf is from Germany. So these are some well-known players in the sheet metal area. Everybody has their own, advantages and their own disadvantages, and all machines are good. And it depends on that you should go for the brand, the factors that depends on choosing these brands on your products, on your capital range, and on your you know flexibility issues. If you have a fixed you know product line, the flexibility might not be a great thing for you, but a little flexibility never hurts, right? So that depends on which machine you should go for, how much you are willing to spend, and what are the things you would want to compromise, and what are the things where you want to take your stand. So that's where these brands will come here. So I just thought that I would mention the brand names to you, and we will not going deeper into brands, but we will see what makes a punching machine into a great punching machine. Like, what are the factors? Everybody manufactures a punching machines, right? So, what makes a punching machine into a great punching machine? So, we will look into that. What are the factors you should look when you are choosing a punching machine? Maybe you can create a white sheet and you can write down the specs and everything. And, at the end of the white sheet, you will understand which is an ideal investment for you. So, okay, things to consider while choosing a punching machine. So these are the things that we have compiled together. You should think, or you should consider when you are choosing a punching machine. So, this is a bird view, and we will take a detailed look on everything in our next following slides. So the first thing would be working range, uh, and then the frame, the frame which machine uses. Every machine has to build on a frame, and the frame plays a very important role in the machine operations and flexibility. So what kind of frame machine uses, what type of transmission the machine has, to deliver the power, what type of machine the provider has chosen, to transmit the power. Is it a hydraulic? Is it a electric? Is it a hybrid? Why should you go for a hydraulic? Why should you go for an electric? Or why should you go for a hybrid? What's an hybrid actually? So we will take a look at that, and then turret. So we cannot leave turret when you are choosing a punching machine. So what makes a turret, or how the turret, can be configured, or how important the turret is. We will take a look at it, and then tools. So, like what kind of tool configuration you can use in the turrets, and we will see about that. And then we have a power consumption. So, purchasing a machine is one thing, and being able to run that machine for a longer period of time without spending too much of currency, or without spending too much of investment is a whole another thing, right? uh, if we may get some cheaper machines, and the running cost if running cost becomes a very high thing, that doesn't make any sense. So that's what we call it as a power consumption. And then we have a programming softwares. So how the programming for those machines can be done, and why it should matter, for the software. And then we have automation. It may not be a prime concern for everyone, but right now we are in Industry 4.0, where our shop floor automation is a key aspect for the manufacturing and everything. And I'm very sure that in next 4 or 5 years it might become mandatory also. So automation plays a very important role in while choosing a punching machine. What can be implemented with the machine, and whether can we add on some options after purchasing a machine, or whether it should be buy with the it should come with the machine itself. So that kind of things we can look into automation. And then, so without any uh, let's start with our slides. So first thing is working range. I hope everybody knows what working range is. It's a very simple thing. So usually the working range refers to the size of sheet metal machine, uh, can process with or without repositions. So usually the sheet metal machines will have a clamps, and the clamps will hold the sheet and will move the sheets along the bed of the machine, and it will bring the sheet into a ram, and where the ram punches the hole or form into a sheet. So there are standard sheets like 2500 into 1250. So that's why in feet we call it as 12 by 8 sheet. So, and then we have in width, we have 1500. So these are the two standards usually the punching machines, plays with. So why the working range matters? So it's very basic. The first thing, if the working range is big, you can process bigger parts. If you have a smaller parts, you can still work with the smaller working range, but again the machining time will increase. So that's the basic idea. If you have a bigger um, working range, you have a much more flexibility. You can go for a lower working range, and that the uh, just looking into the products you have, and you think, okay, I have only small products and I can get my work done with this machine, and everybody is happy. So but that restricts you to take a newer projects or something like that, which may have a bigger parts. But when you have a flagship working range, or when you have a flagship machine, that doesn't matter, right? Because you have that free room in your area where you want to play ball. You can hit anywhere in the ballpark. So the flexibility matters in the working range, and the C frame tends to be more flexible. So this is a frame thing, and we will take a look into that. What's the C frame, and what are the other kinds of frame, and what machines employs what frames, and why the C frame is more flexible. We will take a look into that in a little bit later, next following slides. So more working range tends to less tonnage. So it may not be true in most of the machines, or some of the machines. So if you go for a very long working areas or something like that, they usually, due to the uh, the beams issues and everything, we might able to process a little bit lesser tonnage. So that affects in the thicknesses. So if you again that's a you can calculate the thicknesses. If you want to have 4 mm, you can push your boundaries and working range or something like that. So then we have a clamp dead zone plays important role. So basically, what clamp dead zone means, uh, you know, as you can see in the image, there is a sheet and there is a bed, and there are two clamps holding a sheet. Okay, so clamp dead zone means it's literally what name says. It's a dead zone around the clamp where machine will not be uh, able to punch the process because it is declared as a dead zone to make sure that the to avoid the accidents and to make sure clamp have a good holding strength and something like that. So if the machine has a little bit higher clamp dead zones, it's not like we will not be able to punch there. We will be able to punch there, but for that the clamp has to reposition itself. Uh, we will show that in a little bit area. So video, I have a video for that and I will show you. So clamp has to reposition itself and then the machine has to go there and punch. So this increases the cycle time. So other than that, there is nothing else. There is no more issue here. Then the important aspect of the punching machine, the frame. So there are basically two kinds of frames. One is C frame and one is O frame. You can see in the left side we have a C frame, in the right side we have a O frames. So the name itself suggests why it's called a C frame, because that indicates the capitals, the alphabet C, and this frame indicates the alphabet O. So that's why they are called a C frame and O frame. So C frame is a little bit popular in punching machines. So Euromac and Trump and Muratec and other things employ the C frames, whereas if you go to a Prima Power and Amadas and other machines, they employ a O frame. Both are very good frames and both will provide you a good rigidity that requires for a machining. But the thing is, as you can see here, the C frame has an opening. That means it is accessible from one side. So this means, uh, that's what we call as a throat depth. So you can see here, this is what we call as a throat depth. So if a machine, the working range, we will again go back to working range. So let's say you have purchased 2500 into 1250 working range. 1250 means the throat of the throat depth of the frame. You can process of 1250 depth of sheets. So when it comes to a O frame, that's fixed, because since there is no more area for to insert the sheets or something like that, you cannot able to process the more deeper sheets in the O frame. But when it comes to C frame, the one area is open. You can able to process the uh, even deeper sheets than the rated capacity. Of course, you have to rotate the sheet and put it to the clamps. But let me play a video and that will show you what exactly I'm showing. So I will play a O frame first. So and we will see how the O frame works, and then I will play a C frame, and we will see. So as you can see in the screen, this is an Amada machine. Right now, it has a O frame, and the I will show you. Okay, the clamps are moving and it is able to punch the sheets. It will come a little bit darker and then I will pause it and will explain certain things. The turret is rotating, the tools are changing, and yeah, as you can see in this area, we have a sheet and we have a clamps and we have a turret and everything. So this is the depth I'm referring. So I hope you are able to see my arrow. So this is the depth I'm talking about. Okay. So if you have this machine and they have rated this working range as the 1250, that's it, guys. You cannot use a bigger sheets than that, because there is no room here to accommodate those such kind of sheets. This is what we call it as the O frame. And in frames also there are welded frames and there are casted frames. Of course, everything is casted and then some of the things will be welded together. But most of the some of the providers do provide a complete casted frames. There is a one single piece casted frames are also available. So you know the differences. The casted frame might give you a better life and something like that. As you can see here, this is O frame, and it's restricted by the depths. So let me play, you know, a Euromac video which employs a C frame. So this is a C frame. As you can see here, is open. Just one side is open. Okay, so Nitin Sharma is saying that two frames are welded and bolted. So thank you. So here, as you can see, this in this C frames, you have a flexibility to use the sheets which may bigger than the rated capacity. So little flexibility never hurts, right? So this is turret, and we will come to this a little bit later. Let me close this. So we will go back to this. So that's the basic idea. So if you want to have a little flexibility in your works, you should go for a C frame, or if you are fine with rigid and fixed working areas, the O frame works just fine. Then, okay, this was supposed to be a type of transmission. Okay, I'm missing a headline here, so I will explain. So, okay, so everybody has heard of hydraulic and electric, I guess. So, what makes an hydraulic machine or the electric machines an electric machine? So, today we will just look why you should go for a hydraulic, or why you should go for an electric, or why you should go for a hybrid. I will explain what is a hybrid, and then I will explain why, what are the things that makes them special in their own areas. So first we will go to hydraulic, robust, time-proven, you know, a solid kind of transmission. It's been here since the industrial revolutions, and we don't see a machine with at least one part of hydraulic, without an at least one part of hydraulics there, without in it. So, okay. So yeah, the participants are sharing their thoughts. So please try to share the thoughts there. So the hydraulic is a time proven thing. Here the working principle is pretty basic. You have a hydraulic tank, and you will have a you will have a pump to fluid the hydraulic to a hydraulic circuits, and then you will have a cylinder, and cylinder delivers the power, and you get your work done, right? That's what we call it as hydraulic. Reliable, you will get a constant forces, you will get a good amount, you can achieve a a very good amount of tonnage in the hydraulics. So that's what we call reliable. And then, so when we are using a hydraulic transmissions in the machines and anything, the machine tends to be a little bit cheaper, because since it's been here a lot of time, so we have a the hydraulic machines tends to be a little cheaper. That's what I want to say. And since hydraulic can deliver, a constant pressure and constant forces, and it can be it's the ability of it to hold the ram into a longer period of times and everything. The hydraulic can do a beautiful forming operations. So in the electric is also they also can do a forming operation. I'm not saying no, but if you are if the 80% or 75% of your sheet is forming, uh, it's better to go for hydraulic, because see, the punching machine is all about formings, right? So if that's what you have, it will give you a good forming capability. That's what we call as that's the advantage of getting an hydraulic machine. And it can punch high thicknesses. So usually, I'm sure everybody knows this. So the thickness of the material the machine can process directly depends on the tonnage we have and material of the sheet. So it's a basic calculation. The material, the shear strength of the material into the breadth and width of the tool, and we will get the tonnage we require. So usually all the machines comes around 30 ton. So the hydraulic, the most popular hydraulic machines are 30 ton. So if uh, with the 30 ton we can able to punch up to 6, 7, 8 mm thicknesses and everything. So and there are some manufacturers who produces 50-ton machines also. So it has a very you know capability of punching very high thicknesses. So and again that's an added advantage for the hydraulics. And hydraulic systems tends to be a little slow, as you know. The hydraulic, the liquids has to pass through the circuits and the ram retraction and expansions and everything. So they might a little bit be slow, but they will get the work done. So if we have some constant load of products with you know don't have to stress about the production a lot. The hydraulic is a very good option for you. And then we have high maintenance. So of course, everybody in the mechanical field knows that the hydraulic circuits needs to be cleaned, and we have to make sure that there is no foreign elements in the hydraulic liquids, and it's a little bit of a high maintenance. So that's again debatable. So some of the guys would like to have a eye on their machines, and they would love to do some maintenance and everything. So I just want to put that point over there. The hydraulic is a little bit of high maintenance. Then we have electric. So the electric punching machines came into the market a little bit way after the hydraulic machines are debuted in the market. So it's in this century. Of course, it might have come in the early 2000s or 2005, something like that. So if anybody is not, please help. So in the electric motor, the again this is also a fairly simple machine. In the electric means the ram which provides the punching actions and everything, that is moved by an electric motor. So that's about it. So it's an electric, and you don't have hydraulic liquids, and you don't have to install a tank, or you don't have to do a lot of. It will save you a lot of installation time and maintenance time. So that's what we call it as electric. It's and we since it's a direct driven technology, like a motor is directly connected to a ram with some kind of levers, and it will right on the moment we hit the start button, it will keep delivering the products. So it's faster. It's much faster. So usually the hydraulics can give you the 600 and 650, no, 450 hits per minute, and in electric you can go up to 1000 hits per minute. I'm talking about punchings. In marking, the hydraulic can go about 600 to 650, and the electrics can go about 2000. So the hits per minute, what we can, the number of hits the tool can do in a minute, the hydraulic can do about 450, and the electric can do about up to 1000 in certain models. But usually it will do around 700. So that's the ideal hits per minute for electric, and it's costly. Of course, it's a costly because the electric. The first thing would be if you are doing a punching machine, we would require a little bit of greater tonnage, right? So if you want to do, if you want to have some, uh, if your machine has to deliver some 20 or 22 tons of thicknesses of force, 20 to 22 tons of forces into a sheet, you have to install a pretty big motor for your machine, and electric motors doesn't come cheaply. So, and again, we have to consider the fact that it has to run for a very longer period of time with the it has to be very reliable, and that takes a lot of quality parts, and that makes it costlier to build that motor. So electric machines are a little bit costlier than the hydraulic, and like I said, it's difficult to deliver a high tonnage in this. So usually the electric machines will have some about 20 tons. That's all. The hydraulic have 30 and 50 areas, and some machines have some 22 tons. But electric motors, usually that's what we call it a servo punching machine that can do up to 20 tons. So if you go, and that's also a case in hydraulics also, because if you see a Trump machines, they would offer you only 16 to 17 tons of some punching machines only. They don't have a very big, very high tonnage machines. Whereas Euromac and Murata has up to 50 ton machines, but Trump has only 17 ton machines. So, and these are maintenance free. You know why. So then we have a hybrid. So hybrid is a amalgamation of hydraulic and electric. We will use, so hydraulic is known for its constant force and reliable pressure and everything, and electric is known for its faster machining. So hybrid is an amalgamation to bring the best of both worlds. So here we will use the pressure of hydraulic, and but we will control the movement with an electric servo motor. So everybody wins, right? We will get a constant pressure and we will get a faster tonnage. So let me show you a video. And yes, please. Someone is asking question. Yeah. Okay, we lost him. So I was having a little bit of trouble hearing you. If you can put the question in a chat box, I greatly appreciate it. So I have a small video to show you what exactly a flex hybrid. So, okay. Your innate system that brings the best of two technologies like hybrid and technology. And power consumption is very less because, again, the majority of the force will come with the tonnage. So this is an demonstration of a punching machine with the punching, engaging and everything. So we have a sheet loaded and it's moving. So, okay, this is a area. So you can see this is, we have a servo motor on the left side, and in the right side, we have a hydraulic cylinder. So this is an hydraulic cylinder. The force will come with an hydraulic liquid. But we have a servo motor here, which will control the, stroke length. So how much it should go or how much it should retract. So this becomes, when we control that stroke length of the hydraulic fluid, it will automatically able to punch in a very fast numbers. So we have a cam, coupled to a, we have a cam coupled to a motor, and it will deliver that hybrid system. So hybrid is actually incorporated with Euromac punching machine. That's a patented technology. Nobody can use it without Euromac's permission. So Euromac has a hybrid technology. They have hydraulic machines and they have a pure electric machine. If customer prefers a pure electric machine. We have Euromech has an electric machine and Euromech has a hydraulic machine. But uh, since you need a, it doesn't matter where the power comes as long as it serves your purpose. So we have brought the hybrid. So then we have turrets. So basically there are two kinds of turrets. Um, it's self-explanatory. One is rotary turret and one is linear turret. So rotary turret is where the tools will sit in a circular motion, and linear turret, it will sit in canopies, and the tool will sit in certain canopies, and those canopies will be sitting in the the clamp area, and the RAM basically accommodates only one tool, and the machine will keep on changing the tools according to that. So uh, here you can see the turret is holding a different sizes of tools. There are different sizes, like what is the size of tool that matters. I will go briefly on those a little bit later. So here it's Euromac, Amada, Trump, and Prima Power. All employs rotary turret. We have a rotary turret, and sorry, not Trump. Prima Power has a rotary turret, and Trump has a linear turret. So basically, it's about same, but you know, uh, the linear turret in linear turrets, it will take a little bit more time to change the tools. That's all it is. And linear turret might give you a little bit flexibility on indexing stations, but that will be again, in rotary turrets, it is compensated with the multi tools. And we will come to that a little bit later. So I will show you how the multi tool works and everything. So this is the idea. So if you have to be careful what kind of turret the machine has. And now we have come to tools. So let me go to a sizes first, and then we will go to single tools and how the multi-tool works, and then I will open a turret layout, and I will show you how that makes sense. So the sizes, as you can see here, it's we call the A station tools, B station tools, C station tools, and D station tools, and E station tools. So the station means the size of this is what we call as the hole that turret has. We call it as a station where we can put the tool. So if we are saying A station tool, that means we can put a station tool there. So what makes an A station tool? 0 mm to 12.7 mm diameter tools are classified as the A station tools. So and 24 mm to 31.7 are classified as the B station tools, and up to 50.8 mm tools are classified as C station tools, and up to 88.9 are classified as the D station tools. And in very rare areas, people use E station tools, and up to 114 mm diameter tools are considered as the E station. So I will make this thing very clear. If an A station tool can be easily sit into a B, C, D stations, okay? But a D station cannot sit into a smaller station. I hope you understand why. It's a simple concept. The smaller tools can be fitted into a bigger with the help of adapters. So now you can see here, this is what we call as a D station, and this is what we call as a C station, and this is what we call it as a B station, and this is what we call it as a A station. We have everything here. So right now, this turret has 4 D stations, right? So it has a 4 D stations and some C stations and some B stations. So if I want to put 5 D stations tool in this machine, it's not possible for me because it has only 4 D stations. But I can remove those D station tools and I can put a C station, B station, A station tools. So if your turret has a D station, a lot of D stations, it's a flexible one because you can put any tool in that. You can put a D station, you can put a C station, you can put a station, you can put a B station. But if the manufacturer gives you a specification like, okay, I will give you 2 D stations and I will give you 2 B stations and I will give you some 10 C stations and then I will give you some 16 A stations. That means you are limited to that possibility. You can use only that amount of C stations or that amount of A stations. But if the machine manufacturer has given you a all D station turret, the sky is the limit for you. So right now the Euromac is the only machine which gives you a all D station turret. We were playing a video at that time. We were covering that. So yes, so this is what we call it as a turret, guys. So you can see here, all Euromac has 6 stations. That sounds a little bit less on the number, right? Because we just saw in the image that it has it can accommodate a lot of tools. Well, it looks like it can accommodate a lot of tools, but this small turret can accommodate 60 tools. That's enough for everybody's production, right? So you can see here, the turret has 6 stations already, and with the help of adapters, we can use B or C stations. Okay, we have a station there, we have a B station there, and we have C station there. And one more thing, there will be auto index stations. So auto index means usually the tools in the sheet metal we will be using a rectangular or some shapes and something like that. So the auto index means the tool capability to rotate itself in any direction. So if we tell, as you can see there, you can see some tools are rotating. That means in that station, the tool can be rotated in any direction. So if I want, let me explain in a very simple way. So if I want to punch a rectangle of 100 by 100, and I have a 50 by 10 or 50 by 5 rectangle tool. So first it has to be positioned in a 0 degree, and I will punch the lower and bottom of the rectangle, and then the tool has to be positioned itself into a 90 degrees, and I will do a left and right side. So for this operation, if we basically require 2 stations if the machine doesn't offer you a auto indexing capability, because the tool cannot rotate. So you have to load one tool in a 0 degree and one tool in a 90 degree. But if the machine can offer you auto indexing capability, the machine itself will automatically rotate the tool and it will punch it in a one go. So that's what we call it as auto index. And assuming everybody is familiar with those operations, I will just skip ahead of that operations. So the next step would be we will go towards single tools and multi tools. So everybody is clear with single tools, right? We have it's a single tool, and it comes in all the sizes A, B, C, D. You can put it and you can punch it. But we have a multi-tool operations here. So the multi-tool means multi-tool is a D station tool. So it will have a D station, and in multi-tool we can hose a small tools like you can see here in this. We call it as an XMT10. In XMT10 we have 8 A station tools and 2 B station tools, and it's we have XMT6 here, and here we have 6 B station tools, and here we have some 4 slightly bigger B station tools. So why we should load these into a multi tools, and why we should use multi tools? So like I said, Euromac comes with a 6 D station turret, And out of 6 stations, 3 are auto indexed. It is very important. I will tell you why. Many of the machines will offer you only one or two, up to 4 indexed stations. And right now they are offering the multi-tool capability, but they are not up to par. So uh, if I have an index station and I will take this 10 tool multi-tool and put it in an index station, all the tools inside that multi-tool will automatically become indexed. That's a lot of flexibility for you. You don't have to spend tools for tools purchasing in two numbers or something like that, because you have a lot of auto indexed capability here. So like that, you with the 60, if I load a 60 tool turret here, 30 tool can be indexed, and that's a very high number. So if uh, we can talk about this a little bit deeper, but it makes sense when we see a product. So if anybody wants to know a little bit more about those turrets, shoot me a mail or shoot me a message at the end of the thing. We will take a look about that. Then we have a power consumption. So the power consumption is like, it's important, right? You want to have a you would like to have a low running cost of the machine. You don't want to spend a lot of money in running those machines. So that's where the power consumption comes. So the first thing that the first factor that will affect the power consumption is rated capacity, how much uh, the manufacturers specified. Usually the rated capacities will go around 12.5 kilowatts for other machines, and then uh, some machines offer 7.5 kilowatts. And the tonnage you have, the and transmission, the hydraulics are a little bit uses a little bit more power, and electric kind so hybrid are a little bit of environment friendly, and the speed. So if that again comes to a transmission. In the hydraulic, you can able to punch a high hits per minute, and you will get your job done in a lower time, and automatically you will have a less power consumption. So it's very ideal that you should take a look about uh, how much the punching machine consumes of power when you are deciding to finalize a machine. So again, I have lost here. Very sorry about this. Let me just put okay. So everybody knows that the machines we are talking about are CNC machines. The CNC means the computer numerical controlled machines. So in order to perform a punching operations, we have to program the software. We have to program the machine. That means we have to generate a program, and we have to feed it to a machine, and then machine works. So having a machine is one thing, and capability to program itself to do a very efficient kind of machining is whole another thing. That's very important, because it's not just about how powerful your machine is. Even if we have some high-end, very big, very sophisticated machine, and if you end up doing the program very poorly, you will not get the benefit of using, you know, you will not get the benefit of using the um, machine capabilities. So it should be very ideal that we should make the programming very efficient. So usually the machine providers will give you a software to do a program. So that's why I have to differentiate it between two kinds of software. The software that is provided with the machines and third-party software. So usually the machine manufacturers will give you one basic software, and that will work just fine. See, we have to keep in mind that these are a machine manufacturing companies. So their main focus area will be machines. So they don't give a lot of attention to the softwares. So the Top Punch comes with Euromac, and A-Painted comes with Amada, and the TrueTox comes with Trump, and the NC Express comes with Primapower. It also has a software called Toolus, and Camper comes with Muratech. So these are the softwares that is just enough to get your production running. That's all. So if you have a sheet and if you want to punch it, it will get your work done. So that is their purpose. But if you want to do it in a efficient way, if you want to have some material savings, or if you want to have enjoy some customizability, something like that, that cannot be achieved by the software provided with the machine. That's what we call it as the OEM software, original equipment manufacturer softwares. So that's where the third party software comes. So the third party software means it's a thoroughly a software company. It's a complete software company, and they invest all the resources in a software implementation. So Mr. Govind is requesting me to show a slide 1 to 4 again. Sure, sir. I will just complete this, and I will go back to 1 to 4 again. So
after complete.
Yes, sure, sir. So third-party softwares they are investing all the resources into developing the software itself. So the most well-known brands in the sheet metal market are the Metallics and Redan. So Metallics is from Israel and Redan is from UK. So in these, you will have a very customizable operations for like the nesting efficiency will at least say up to 10 to 15% of material worth of material saving in the soft sheets. So uh, I would like to request you one more thing. So sometimes the Zoom tends to close your meetings abruptly at the middle of the meeting. So if you find yourself disconnected from the meeting, uh, please reconnect again. We will be here. So if anybody got disconnected during the meeting, please reconnect. We will be here. Okay. So coming back to the softwares. So these third-party softwares will work. They will save a lot of materials for you. So usually they will cost you around 4 to 5 lakhs, depending upon the modules you choose to use, because they will have a lot of capabilities. That depends on your production. So usually those softwares will have a return of investment period in 1 to 2 months. So if you invest some 5 lakhs in third-party software, you will get your return of investment in 1 to 2 months, and next will, in a year you will end up saving materials worth 1 crore or 2 crores. So that is very important. So some of the machines comes with a third-party software. So like the Euromac, they have a top punch, and that is enough to get the machine running. But they want to invest all the resources in the softwares, and they don't have machines, and they don't want to concentrate on machines. So they will give you a third-party software with the machines, and that's again subject to matter during the negotiations and anything. But they will give a third-party software. So that means you will be able to use your machine to your 100% potential. In the programming software given by the machines, you won't be able to use the machine up to your 100% potential. So if you have a third-party software with you, it's an ideal scenario. So my colleague is also attending this, webinar. So if you want to have a demo about, if any attendees already have a software machineries and they would like to give a, they would like to take a demo on third-party software, why they should implement a third-party software, we are happy to give you a demo. So, and Then we have automation. So, like I said, it's not everybody's cup of tea. So, but we are in industry 4.0. So, uh, uh, we should look into automotive options because uh, the labor is again a very complicated area, not like something like that. So basically, automation in sheet metal punching means uh, we can automate the machine to load the sheet itself, process it, and unload it. That's what we call it as a sheet loader and unloader. And we can automate the machines. So usually what happens is when you finish the punching, when you finish the sheet, you have to manually remove the parts from the sheet and send it to the next level of production. So if you want to eliminate that area, like you don't want to manually remove the parts from the sheet, the part should immediately detach itself from the sheet, and you want to uh, you want to process that part as soon as it's punched. That's where the shoe door comes. And then we have a part picker of sorting cells. So once the part is part, we have collected the part in shoe doors, we can automate the machine to pick that part and sort in a certain way where it can be processed to, next views. So I will show you one brief video with implementation of all three uh, technologies. Like we have a it will have a loading and unloading, and then it will have a shoot, and then it will have a part picking. So many people implemented many different technology, but basically the idea is this. So you can see here. So we have a punching machine, and then in left side we have a sheet loader. So the operator will load sheets into this, and from here the machine will take care of thickness. So it is checking the thicknesses, and it will load the sheet. So this is what I was telling. So this sheet has been completely processed, but we have to manually remove those parts. But if some customers don't want to do that, so that's where the shoe door comes. So now it will unload the sheet, and we will load the new sheet. So right now it is loading a new sheet, and the punching starts. So it is punching now. Once the part is there, the shoe door opens, the part will come. Now the robot will pick up the part, and it will sort itself into its area. So we can designate where it needs to be dropped, and it will automatically drop. So now you can see it will finish one more part, and that part will automatically shooter. See, the shooter is dropping that part, and it will come in the conveyor belt. That part will automatically pick it, it will drop it. Simple, right? So this is what basically happens. So these automation options does not come cheap. That's very much sure. But the productivity you can offer. So this is a press brake. From here we can offer a press brake area, but let's not go to that. We can have one more session for that. So we can automate the machines to go for a sheet loader and unloaders, and we can have a shoot doors and parts. And these are upgradable options in every machine. No machine manufacturer will force you to go for these any options and force those economical repercussions on you. It's these are exclusively optional. You can choose these options only if you want to. So that's what I wanted to tell you. So that comes to the end of our presentation. Please, for Govind sir, I will be just going through the 1 to 4, uh, you know, frames. If anybody, so yes, sir. The first,
Sir, I
I, yeah, please. Yeah, someone was asking a question.
the Govind, I have some question. After
Yeah,
the 1
please.
to 4 slide, I will ask.
Okay. So first slide is just a cover page, and second, we have a punching machines. It's basic definitions of punching machines, and then what is the thicknesses of punching machine can process 0.5 to 6 mm thick and everything, and we have well-known brands. Euromac, Amada, Muratec, Prima Power, Trump, Euromac, and Prima Power from Italy. Amada and Muratec are from Japan, and Trump is from Germany. So in the fourth slide, we came to asking a question like, what makes a punching the great punching machine? So from here, we finalize some factors to consider while choosing a punching machine. So yes, sir, Govind sir, please ask your question, and we'll be happy to.
I have a question. First question is such type of machine, punching machine. What is the major there is a major application of the such type of machine?
So punching machines' major applications will be enclosures, like the power, the control panels you will see in the electrical industries. So the building, the construction is never out of business, right? There will be always a construction things happening, the airports, the complexes, houses, and homes. For that, we need an electrical connection, and to have those electrical connections, we need a control panel. We call it as a electrical enclosures, and we can use these machines to manufacture kitchen equipments. We can use these manufacture aeronautical components. We can use this for agricultural components. We can use to manufacture furnitures and lots of things.
Okay, sir. Second question is for me. You have told ABCD are the sizes of the.
Yes. Sizes of the tools.
Then there are you can put the ABC in the E turret. Okay. ABCD in the E tool. Okay. In the E turret, can I put number of A turret in the one or only one turret in the E tool?
Yes, sir. That's what. So usually I will be taking an example of D station, because E station is not a heavily used station. D is a very popular station. So if you that's why the single tools and multi tool comes. If you put a single tool in D station, that's only one tool.
Okay.
But if you use a multi tool, here you can see a multi tool. I can put 8 A tools and 2 B tools, and if you put that station, you can hose up to 10 tools. So with the help of multi tools, you can load more than one tool in one station. So that's what we call it as a.
And if the D, there is a D tool. Okay. If I want to put A tool in the number 3 or 4, can I make such type of arrangement?
No, if D station already has a D tool, you cannot put any more tools. But if you want to put, if you want to put 4 or 5 A station tools in D station, you can use a multi tool, and you can put it. You can put that multi tool in there, and you will have a multiple A tools or B tools. You can put multiple A or B tools in D station, sir.
Okay, sir. Sir, the third and last question. You have some automations. You show the automation of the lifting of the. Okay.
Yes.
And have you provided the separate such type of arrangement?
Like you just want the. Yes, we can do that. These are all completely optional. we can
Okay.
if any punching machine already has a chute doors, it's very important that the part has a conveyor belt or something like that. uh, we can provide the, you know, uh,
Separate.
separate
Separated.
separate picking system also we can provide it. We can give a separate sheet loader and unloader. We can give a separate picking cell. We cannot give separate chute door. That has to come with the machine. But the first and last options can be given independently, sir.
Okay. Sir, another question.
Yes, sir.
In
Please, please.
particular, yes. If yeah, I'm using that particular, you are told there are some detection system for the punch
Mhm.
panel. Okay,
Mhm.
blank pan. How they
Mhm.
detect the thickness of the particular part in the system?
Uh, can you repeat your
You
question,
told
sir?
me
I'm
there
sorry.
are the huh?
I'm losing you in the audio. Can you repeat one more time?
Sir, you have told
Mhm.
there are some thickness detection system in the
Yes, sir.
particularly blanking.
Yes.
Yeah.
I will show you. So here, when I started the machine, so this is a sheet loader, right? So this is where we will load the sheet, and you can see here
Okay.
it is picking up a sheet now. Okay, and then did you see there is a arm just engaged? This is a thickness
Yeah.
detection. So I will show
Okay.
you one more time in one
Yep.
piece. So it will
Okay.
come and it will engage it and it will detect the thickness. So that is where the
Minimum thickness.
usually we can process from 0.5 to 6 mm.
Okay. Okay. Thank you. Thanks, sir.
Uh,
Thank
oh,
you, sir.
thank
Thanks
you.
a lot.
Yeah, thank you very much. We always welcome a lot of questions. So Vikas Tapir has put a question in chat box. So that is, what is the minimum bridge can be achieved during blank nesting in a turret punching for various thicknesses of parts? So if you have a rectangular parts or just a blank nesting or something like that, we can achieve uh, zero bridge cutting. I will show you how. So zero bridge cutting means we will essentially shear the parts. We have a shearing tools for that. So let me show you a video for that. I hope.
Okay.
So, presentation. This is what we call it as a shearing tools. So now it has engaged it.
Okay.
You can see here it is essentially shearing the sheet. Okay, this is a roller offset. I'm sorry. Yeah, now it is sharing. Okay, I have a better video for that. I'm sorry. This is, we call this as a roller tools. Just a minute, it's right here after this. As you can see in the lower right side, we have a sharing tool.
Okay.
So usually, I have to tell you, so usually the sharing tools work for linear lines or straight lines, something like that. So if you want to have some intricate shapes cut or something like that, the minimum braid size we can go up to is like we have a tools for 2.5 mm wide, so we can go up to 2 mm wide of bridges. But with the use of ultra wide, ultra, there are some ultra tech tools from Mate. We have achieved 0.5 also. So,
Okay. Is it depend on the part thickness or sheet
yes,
thickness?
yes, it depends on the thickness.
Okay.
Thank you. So thank you so much for that
Thank you.
question.
Thank you. Thank you.
So yes,
You told minimum, but maximum blank size
6 mm, sir. We can share 6 mm.
6 mm.
Yes, we can share 6 mm.
No, it is the thickness, but the size, width and length.
So width and length is like a working range. So the working range of machine is if it's a 2500 into 1250. So we can share everything that is in a working range. So
Okay.
2500 into 1250 is the number.
And one last question, sir. Sorry. The safety
Please.
of the operation.
Like what kind of safety, sir?
Like this is the rotating part. Okay. And tools are rotating and there are punching operation. Some people can put the hand in between the two part and punch. What type of safety you have?
Usually the turret what is rotating, in order to able to reach that turret, you have to remove one table actually. You will be able to reach that turret only if you remove that table, sir. I will show you that table. It was here.
And
one second, I will show you a video. You will understand better. So. In this, you can see here, in the left hand side, operator will remove the table. You can see. See, he has to remove the table in order to access that turret, sir. Okay. If that table is, not engaged, if the table is in low position, the machine will not start. And one more thing is, we can have a laser mounts in the beginning of the machining area. We can put a laser mounts that we call it as a photo sense. If any personnel go beyond that area, the machine will automatically stop. So we have that safety operation also.
what is the changeover time for the particularly turret or the tool changeover?
The tool changing time is 45 seconds. Sir.
45 seconds. Okay.
Yes, 45 seconds.
Thank you. Thanks a lot.
Yes. Thank you. So, and phone numbers for anybody who wants to contact us later. You can take a screenshot of this. So, I assume everybody is happy with the webinar and all of your questions are fulfilled. So, please keep watching our spaces in LinkedIn, or please be in touch with one of our representatives. We might have a few more webinars lined up in next few days. So thank you very much. Okay, we have one more message here. Let me see that. Okay, Mr. Kishore has asked, thank you. Thank you, Mr. Kishore, for asking the questions. So it was nice spending a good amount of time with you all. I hope this webinar was fruitful to you, and good evening. So enjoy the rest of your day.
Naveen and Shivakumar sir, thank you. Satish here, and I hope my team has really learned some additional things today. And thanks for arranging such a show.
We are happy to help, sir, Satish sir. If your team still has some questions, we will be here to answer you in any amount. Thank you. So thank you, everybody. Have a nice day.
Okay, sir.